Rosemary?
Something made of rubber?
Rubber? Yes. And let's try other things, too.
Other materials are suggested by the pupils, and they make plans for testing their ideas. They are developing scientific attitudes by collecting more evidence before arriving at even a tentative conclusion. The stage has been set for real science learning experience.
Now, Bob, it's your turn. You've been doing some experimenting. What have you found out?
Well, I found out that north against north won't stick, but north against south will stick.
That's what you found out. Now, what is it you think you discovered with those bar magnets?
That north against north are the same, so they won't stick, but south against south won't. The south and south won't stick because they're the same too.
Remember when we were talking about magnets, we said the word attract, and we were talking about stick? Well, now we can add another word to that. When they don't stick, as Barbara has told us she found out, we can say they repel. So you found out that sometimes they are attracted, and sometimes they repel. Is that right?
Yes.
Well, let's look at them. Attract, pull together, repel, push apart. So you found out that sometimes they attract and sometimes they repel. Now, why do you think that is? Jennifer? Well, that's what we'll have to find out, won't we? Does anybody have any other questions? I noticed you had your hand up, Catherine.
Well, if them bar magnets stick together, then why don't the other kind of magnets stick together, like horseshoe magnets and U-magnets?
So we need to know if it's the same thing is true with magnets of other shapes, don't we?
Yes.
And those are two very good questions. We can find the answers to those two later, too. Thanks. All right, now I think it's your turn, Jonathan. You're about ready to tell us what you think you've discovered when doing that experiment.
The magnet can pick up metal.
That's right. Now, do you suppose a magnet can pick up all metal?
No,
What do you think, Deborah?
I think yes.
You do. So how are we going to find out for sure whether it will pick up all metal?
We can experiment.
That's a very good idea. Who would like to experiment with Jonathan on that? Deborah, would you like to? All right. Go right ahead, because we've got a good question here.
Since the children will test their new ideas through more experiments, learning continues. The teacher has skillfully guided, but has not dominated the class.
Now, what have you discovered?
I discovered this is acting like a magnet can pick up paper clips.
Well, you discovered that you can magnetize your scissors. Does that make you wonder about anything else? No? Well, I wonder if you can magnetize anything else. Thomas?
A nail?
We can try it and find out. I wonder if you can magnetize any other metal. Like a penny, perhaps. Do you think we could?
After more of this kind of stimulation, the teacher has collected the questions raised and written them on the chalkboard. As you will see, the answers to these questions contain the basic information about magnets. Let's see what pay dirt she has struck. Will the force of the magnet go through other things besides wood? Why do the ends of magnets sometimes pull and sometimes push each other? What things will magnets pick up? How can we make one magnet out of another? Here we have seen an example of setting the stage for learning by providing simple experiments to whet the curiosity of children. They have been stimulated to wonder. They have encountered problems. They have some bases for formulating questions. They are perplexed. The groundwork for exploration and investigation has been laid. Not all of the problems that form the basis for science lessons are part of a planned unit of work. Some arise incidentally and spontaneously, something that happens in the classroom, a newspaper article, a TV news report, an object brought to school by one of the pupils. But even in such cases as these, the stage still must be set for learning. Let us watch such a situation where a pupil has brought into class her collection of shells. Here, before class begins, we see her showing the shells to her classmates, explaining where she found them and telling a few things she knows or thinks she knows about them. Our teacher notices that since there's considerable interest, it seems advisable to devote a few lessons to a study of the collection, not only because it is a fine example of spontaneous pupil interest, but also because it ties in with their previous study of living things.
Suppose we spread that shell collection out on the science table. Then each one of you could see each one of the different items. Don't you think? We might even use a magnifying glass. And then you could have a much better look. What would be some of the things you'd look for? Anybody got any ideas?
Initial experiences of observing the shells have already brought a worthwhile list of questions the children want answered. The teacher has added some questions of her own to tie these lessons in with the previous study of the problem, how are animals different from each other?
Well, how can we find the answer to some of these questions? Ellen?
Look in the book.
Mark?
Find pictures of shells that look like ours.
Very good. Kathy?
Go to a museum.
Fine. Donna?
Look in the movie.
Yeah, that's a very good way, too.
Here we have seen an example of setting the stage for learning science through an incidental experience by providing an opportunity for children to observe. When they observe, they are almost sure to wonder, and when they wonder, problems arise. You've seen examples of how teachers and children have together set the stage for discovery. Remember that perplexities arise from experiences, and these should be planned with this end in view. Children ask questions and formulate problems only after experiences that make them wonder. Good teachers are ever mindful of the importance of a good beginning, good motivation in any learning venture.
Got it? Richard?
Well, some sort of metal.
Now what? What else do you know about it, Richard?
This is vertical.
That's right. It goes right through. I wonder if anyone can use these materials to do an experiment to show what happens when it's heated.
Really? Put the ball over heat and it will melt so that it won't stick to the ring properly.
Just the ball over the heat. Well, that's a good one for us to try. But when we do this, we may decide that there's a better word than melt to describe what happens. All right, let's get ready.
The whole class is now familiar with the large problem to be solved. As a third technique, the good teacher makes provision for active participation by the pupils themselves. She calls for volunteers and then divides the class into 3 groups, each with a specific problem to solve and the equipment necessary to solve it. This permits her pupils to be involved in a variety of experiments, all related to the solution of the major problem, what happens to materials when they are heated. One group will experiment to discover what heating does to the gases in the air. Another to discover what heating does to a particular liquid, water. The third group will experiment to discover what heating does to a particular solid, iron. The next technique, the fourth, gives pupils the opportunity to learn from one another and an excellent chance for the practice of language arts skills. When the experiments have been performed, each group in turn describes its findings to the class as a whole. Let's hear some of this reporting process.
Let's start over here. Donna, can you do that?
Well, our group discovered that when air is heated, it expands.
All right, you reported that well, but do you think it's true of the same thing happening with all gases? How could you find out if it was? Richard?
Well, we can look it up in a book.
How else?
Well, we can do the same experiment only using other gases.
Very good. Gary, why don't you tell us what your group has discovered?
Our group discovered that when water is heated, it expands.
Now, how do you suppose we could find out if this is true of all liquids? Maureen?
We could read it on a book.
Anybody else? Robert?
Well, we could test or experiment with them.
Those are both good suggestions. All right, Douglas, suppose you give us the discoveries of your group.
Well, if you heat an iron ball, you find that it expands, so it cannot fit through the iron ring.
Very, very well put. Just one sentence, too. Now, how could you find out if the same thing is true of all solids when they're heated? Mary?
But it could be taught.
Anybody else? Ira?
My experiment.
She now employs a fifth technique. She encourages her pupils to find in everyday life examples of materials expanding when heated. To be successful, carryover must be taught. She encourages her pupils to relate the science learned in their classrooms to their environment. This can make science interesting and valuable because it now is meaningful.
Now, between now and the next time, why don't you see if you can find different places where all solids and liquids and gases are expanding? Where do you think you might look? Douglas?
In the kitchen.
Mary?
Look at books and find out.
Oh, books are always a good source. Ira?
Might look in the garage. And if the tire gets too hot, it might burst.
That's a very good idea. Now, I suggested that you look for places where materials are being heated. But while you're looking, see if you can find out what happens when the same materials are cooled.